This is a Math 2 summary video for the task titled Pascal's Pride. This is a solidify understanding task. The purpose of this lesson is for students to multiply polynomials. Multiplying polynomials can require a bit of skill in the algebra department, but since polynomials are structured like numbers, multiplication works very similarly. When you learn to multiply numbers, you may have learned to use an area model. To multiply 12 times 15, the area model and the related procedure probably look like this. Here's 12 over here on the left and 15 up top. So 12 was broken down to 10 plus 2, and 15 was made into 10 plus 5. 10 times 10 was multiplied. You have this large area of 100. 10 times 2 made these two 10s, and then 10 times 5 made these 5 10s, and then 5 1s times 2 1s equals 10 1s. So there are the 10 1s, the 5 10s, the 2 10s, and then that big 100 square. Then when you add, you get 180. You may have used the same idea with quadratic expressions. Area models help us think about multiplying, factoring, and completing the square to find equivalent expressions. You'll learn more about completing the square in an upcoming unit. We modeled x plus 2 times the quantity x plus 5 equals x squared plus 7x plus 10 as the area of a rectangle with sides of x plus 2 and x plus 5. The various parts of the rectangle are shown in the diagram below. So remember, in these diagrams, the long sections represent a length of x and the short sections represent a length of 1. So x plus 2 is this long length of x plus 2 short sections of 1 on the side here. And then x for the long section, and then 5 1s. So x times x gave us x squared. X times 2 gave us these 2 x's. 5 times 2 gave us these 10 1s. And then 5 times x gave us these 5 x's. Now let's look at a couple of examples for how to multiply polynomials. For 6a, I'm going to use something called the box method, which is similar to the algebra tiles and area models that we just went over. First, I'm going to start by drawing my box. Since I have 2 terms, I'm going to make sure that my box has 2 rows. And then my second polynomial expression has 3 terms, so I'm going to make sure that I have 3 columns. I'm going to put x plus 5, and then x squared minus x minus 3. Now I multiply. So the property that I'm using to be able to do this is called the distributive property. So I'm going to multiply x times x squared to get x to the 3rd power. X times negative x will give me negative x squared. And x times negative 3 gives me negative 3x. X squared times 5 gives me 5x squared. Negative x times 5 gives me negative 5x. Negative 3 times 5 gives me negative 15. Now I'm going to combine like terms. I only have one x cubed, so I'll write that down. Now when I look at my diagonal, I have 5x squared plus negative x squared leaves me with a positive 4x squared. Negative 5x plus negative 3x is negative 8x, and negative 15 comes down. For my second example, I'm going to use the distributive property again. This time I'm not going to organize my work in a box. I'll just use arches to make sure that I multiply x times everything in this second set of parentheses, and then multiply the negative 2 times each term in this second polynomial. X times 2x squared is 2x to the 3rd. X times 6x gives me positive 6x squared. And then x times 1 is plus 1x. Now multiply the negative 2 to each term in my second polynomial. Negative 2 times 2x squared is negative 4x squared. Negative 2 times 6x is negative 12x. And negative 2 times 1 is negative 2. Now I'll combine like terms. I'll bring down the 2x cubed, and then 6x squared minus 4x squared is positive 2x squared. X minus 12x is negative 11x. And then this minus 2 is brought down. Remember that when you are multiplying, if you have the same variable, you add the exponents. For example, x times 2x squared was 2x to the third. So x has an exponent of 1. 2x squared, this x has an exponent of 2, so I add the exponents when I'm multiplying. The reason why is because if I have 1x and then I represent 2x squared, I'm going to represent that times 2x times x, because this is 2x squared. That means I have a total of 3 x's now. So I have 2x to the third power. When I'm combining like terms, when I'm adding, I do not change the exponent. For example, let's look at 6x squared minus 4x squared. Think of x squared as a literal square that has dimensions x by x. This is x squared. This means I have 6 of them. Then if I take 4 of them away, I'm left with 2x squares. Alright, that's it for this video. Thank you for watching.